Hello, everybody. Is everybody having a magical day? All right. It's Magic Kingdom, right? So it's me, and then Watson, and then the party, right? So let's get to this. What I would like to do is, this is a very cool conference. The first time for me here. I've listened to a lot of the discussions, and obviously it's an IoT conference. Everybody speaks IoT. Everybody's pretty fluent in IoT. We do IoT at GE. I'll touch upon that a little bit, but I actually want to talk about kind of the next thing above it, and that's the applications for IoT. And that's what my session is really all about. So let's dive into this. A few data points to get us warmed up. A lot of the other speakers had data points like this already, so you've probably heard it all, but some of them are really interesting. 1 billion installed meters by 2020, smart meters, I should say. Connected light bulbs, somebody mentioned, when you are throwing them away, don't forget to delete your Wi-Fi password out of those light bulbs. Not sure how you do that, but I definitely remember that. Connected cars, right? They are growing very fast. A lot of cars are connected. And terabytes of data coming from things like GE turbines and other GE type of equipment. I'm not going to be necessarily talking about GE equipment here, but it's a big company I work for now. Now, there is, of course, two sides of IoT story. There is the IoT that the press is writing about every day, which is kind of the consumer IoT. And then there is the business, or if you like, industrial IoT. And those are not the same, right? I mean, sure, the idea is we have smart devices, we are connecting them together, we are collecting a lot of data and doing something useful with it. But in the consumer world, the impact on the device is relatively small. About the worst thing that can happen to you is dropping your iPhone into a toilet bowl or something like that. When it's an industrial piece of equipment, a big CT scanner or a big wind turbine or jet engine, the equipment is actually mission critical, right? You don't want the jet engine to stop working ever. And so there's kind of a major impact there. In terms of the data, my kids can consume gigabytes per day on YouTube. But it's kind of peanuts compared to the petabytes we are talking about in the industrial IoT world. Security, consumers, let's face it, I mean, they are willing to give up their privacy for security, their privacy for convenience. And so security, while it matters, people don't really pay a whole lot of attention to it. In the industrial world, it absolutely matters, right? Again, we are dealing with mission critical equipment. Without security, a lot of things could go really, really wrong. Computing, for the most part in the consumer world, it all happens in the cloud, right? It's all kind of reactive, whereas in the industrial world, a lot of the computing has to happen on the edge or in the fog, as we've learned this morning. So there's a different approach because, you know what? A lot of the industrial equipment is actually not smart. You have to put sensors on it, and then that computing needs to happen somewhere. And also, of course, you need to deal with all that data coming in. And last but not least, and that's where we come in, service. In the consumer world, we don't really want service, right? As consumer, I don't want to have to deal with service. The vendors don't want to provide me any service. So if service is non-existent, that's kind of ideal. In the industrial world, equipment needs to be serviced on a regular basis, otherwise it stops working. And so it's really important, it's critical, often regulated. Now, the data, right? So there's been a lot of different stats, and I was kind of reading prior to this presentation as I was preparing this deck, and there are some phenomenal statistics about the data volume that is being created. You see a gas turbine, right? 588 gigabyte per day, right? There are apparently 10,000 sensors in a single wing of a aircraft. So you can only imagine how much data you are collecting from that. On average, 1 terabyte of data in a single coast-to-coast flight or transatlantic flight is being generated. Connected cars, right? 25 gigabytes per hour. Right, so if you do a trip from Orlando to Miami or from San Francisco to LA, you are creating serious amounts of data. Compared it with something like Twitter, which seems pretty overwhelming, it's only 8 terabytes a day, right? So couple jets are generating that and more every day, which is pretty staggering. And so, that kind of brought us to the whole notion of Internet of Things, and there's a lot of elements that go along with that. Of course, it's the sensor technology. There's a big difference between connecting smart devices that actually have had the sensors and the computing power in them from the beginning. And, from our standpoint, we see a great adoption in areas like medical devices, right? I mean, every CT scanner has a computer built in, so it's not very hard to do a lot of data collection already and actually deal with the data right there on the device. Whereas if it's a gas turbine, it might not have any computer, right? So you put sensors on it, you need to figure out how you get that data off those sensors and what do you do before you start sending it into some kind of cloud. That's where the data sampling comes in, right? So this is where you kind of need to figure out how am I going to actually get the data and move it along. Then the data processing, this is what everybody's kind of talking about. This is where the IoT magic comes in, right? This is where you start connecting the different pieces of equipment. You start assembling the data together, and you start applying some analytics. And then there's a whole bunch of data science, and all of that is for some kind of benefit, right? And G likes to talk about this power of 1%. Where, in an industrial environment, 1% efficiency improvement can yield billions and billions of dollars, which is pretty staggering, right? So people are willing to actually do quite a bit of heavy lifting in order to improve by just 1%. And often it's, of course, much more. So that leads to kind of the notion of an industrial IoT platform, right? And the IoT platform needs to answer some of the key questions. How do I securely connect all my equipment? And that equipment may be from different vendors, right? How do I analyze the data and, understand it's a massive amount of data. So, the traditional analytics tools might not be applicable in this case. How do I deliver real-time information to the people who need it the most, which is usually the people who operate the equipment? And then how do I protect the data and how do I comply with all the regulatory requirements? Because let's face it, most of industry, most of B2B is regulated, and regulatory requirements are kind of part of the daily life. And so this is where we ended up with kind of an industrial IoT platform definition. GE's platform is, of course, Predix. There are many other environments. Some of those are shown here at this show. But what these platforms usually do is they figure out how to connect devices. They provide some level of industrial analytics and data management capabilities. They usually allow us to do all of this in the cloud so that the connectivity is kind of easy. And they provide some layer of security. Right? So that's kind of IoT as most of you probably know it. And usually people, usually a lot of the discussions that I hear about go something like this. So we have equipment, we have sensors on that equipment, we collect data, we figure out a way how to get the data off those sensors, load it up into some kind of data lake or data pond or what have you. We put it in the cloud, we apply analytics, and we generate actionable insights, right? It's kind of the favorite term that people talk about, actionable insights. And here I say, and so now what, right? I've learned about an actionable insight. What do I do about it? Right? It's a nice thing to know that there is something that I should be doing, but how do I actually execute that? And so this is where the whole notion of IoT applications comes in, right? Because the platform and all of the stuff that we are talking about here usually provides all that functionality from connectivity, security, management, analytics. All of that is part of what the platform provides. So I might actually end up with some insights that I didn't know about, right? That's great. But now it's up to the IoT applications to actually action these insights, right? If they're actionable, I need to be able to action them. And so this is where the capabilities such as maybe I make some predictions, maybe I provide some diagnostics, maybe I allow people to collaborate together in order to figure out what to do next. Maybe there'll be some recommendations. Maybe I will automate some business processes. Think about that, right? So this is where applications come in. And this is where, kind of the difference between what the platform gives you and what the applications give you comes in. And of course, that's what we do, right? We deal with some of these applications. Applications are what essentially makes a platform. And I kind of took some cheesy screenshots from some cheesy application environments that you all know, right? But what would Windows be without the applications, without Microsoft Word and Excel and PowerPoint? You wouldn't be able to really do a whole lot with it. How about your smartphone in your pocket? Without applications, it wouldn't be particularly useful. Yeah, it provides connectivity, it collects data, it does a lot of cool things, but the applications are what makes a platform. And so applications are very critical, and applications are where the actual benefit, the business value comes in. So if there is kind of one message from me to you today is, when you think about the benefit, it's not the connectivity, it's not the data itself, it's not the insights, it's the business value of the actual application. So now, here comes the slide that, is the magic. I've spent several days pulling all of this together. The types of IoT applications that I have found, and I guarantee you that you will come up with examples that are not on this list, so this is not an exclusive list or exhaustive list, but there's a number of different types of applications. So the first one is remote monitoring, remote diagnostics, remote controls, remote management. That's what we see a lot in the consumer world, right? My Nest thermostat, whenever you look for IoT applications, it comes with autonomous vehicles and home automation. Those tend to be kind of the first things, right? All these Wemo switches that I have installed at home, and the smart locks, and I have a smart ringer. All of that falls into this category, right? That's basically remote monitoring, diagnostics, control, and management. Cool stuff, important stuff. If you think about it, this is not new. A lot of this existed long before we've had IoT, right? I mean, the space shuttle had some remote controls 30 years ago or 40 years ago. So it's not new, but it's very, very useful. The second one is inspection, testing, and security systems, right? So now you are monitoring for something. Whether it's temperature, level of corrosion, maybe pressure differences, liquid flow or gas flow. You are looking for media, so collecting pictures or video. LiDAR, right? So that's where you are looking at looking at a power line and examining whether or not the trees are too tall to interfere with the power lines. There's an application for that you can apply on the drone imagery that actually comes in here. Drone-based inspections, motion detectors, right? All the security, home security, industrial security usually falls in here. Again, a lot of really cool stuff. At GE, there are other groups that I don't really work for, but like in oil and gas, they have these things, they call it a pig. And it's basically this little carriage that drives through the pipeline. And you've seen it in the James Bond movie, right? But it's actually very useful. It's got sensors on it, and it monitors corrosion levels of the pipeline from the inside and sends the data back. It's really cool stuff, right? So that all falls into this category. Then we have location applications, right? Fleet monitoring, vehicle monitoring, dynamic route planning, in-transit visibility, right? Kind of the eye of God or whatever they call it at Uber. Actually, Uber probably falls in here in some ways. Autonomous vehicles, right? That all fits into this category. So location-based applications. Then we've got wearable safety system. I saw a vendor at this show showing some personal safety, right, for workers. We obviously deal with a lot of service type of environments, and I'll talk about that in a minute. And crew safety and worker safety is very critical, right? You want to know that if somebody falls off the stage, that they have fallen off and they might need help. And there are sensors for that, so you can actually do that. Wearable gas detection, right, for miners and people like that. Fatigue level monitoring for drivers and train operators, people like that. Industrial control systems. So these are all those, SCADA and asset performance management and digital manufacturing type of systems. So now you have industrial level equipment, and you are not just monitoring and not just collecting data, but you are applying some controls to it. You're actually doing something, maybe changing the operation of the equipment based on your findings. Then we've got business applications. Field service management, that's what I do. I'll talk about it in a minute. But also inventory management, supply chain management, warranty management. So if you are dealing with any kind of movements of parts or goods, and you are somehow tracking them in a business application, it falls into this category. Okay, this is the last one, so now you can take your picture. Big data analytics, right? So this is, I think Watson is coming after me. That probably falls in here, right? So this is kind of the decision making. Maybe it's a doctor doing a diagnosis based on some data coming from different X-rays and what have you. Maybe it's some manager making some, trying to make some business planning for next year based on some data. So this is kind of the decision making types of applications, right? Probably not an exhaustive list. I'm sure, in fact, if you find more applications, let me know. But it's kind of a good start, right? So here we go. What do we do at GE? So I mentioned we have a lot of machines that I don't know much about, from gas turbines to wind turbines to locomotives to jet engines to MRI scanners, CAT scanners, a lot of different divisions, right? And all of them have thousands and thousands of sensors. So we have data. We also have understanding of the data. We understand the equipment. And we have an industrial IoT environment to get the data together. We call it Predix, right? We also have an application called Asset Performance Management. So it falls into one of my 7 classes, right? And this application allows us to analyze the data and do something useful with it to get some insights. And then we also understand that you need to action those insights. And the number one action in the industrial world is usually dealing with the equipment itself. Because at the end of the day, it's about some kind of outcomes that you want to achieve. And at the heart of those outcomes is industrial equipment, right? So making sure that that equipment's running is kind of a priority. And that usually starts with service. So that's where we come in as ServiceMax. We are the application that basically manages the service delivery process. So if you look at the world of industrial equipment, at the heart is the equipment, and the equipment needs a couple of things. Number one, I made the case, is service. You need to make sure that it's working. Number two is some kind of monitoring and kind of the operating analysis of the equipment based on the data that you are getting, right? So this is where the APM application comes in. And of course, you also need some customer data, especially if you are not the operator, if you are the manufacturer of the equipment. You want to know who's using it and how you use it, right? But at the heart of it is the equipment. And so what I would like to do, I'm going to click back. What I would like to do is briefly just outline the top 2 areas. I'll talk about the APM application and the service application so that you get a feel for examples of applications and what they do. So the asset performance management basically deals with kind of the traditional dilemma that you have with every piece of equipment. How am I going to operate it? Am I going to optimize for cost, for performance, or for reliability? Right? Those are 3 different things. When I went back to business school many years ago, I've kind of learned one trick. Whenever you need an example, pull one that everybody understands. That's cars, right? If I'm driving a car, I can drive to optimize the cost, I can drive to optimize the performance, and I can drive to optimize the reliability, right? A Formula One race team is only focused on performance, right? Reliability, hey, the race is 2 hours, who cares, right? Cost, no limit, right? Any money you can spend. It's all about performance. If it's a 24 hours Le Mans, well, reliability becomes a much bigger factor all of a sudden, right? Performance is important, but it needs to last 24 hours. It's a whole different ballgame all of a sudden. So that's a very different approach. And we call that asset strategies, right? This approach is basically all asset strategy. And asset strategy means that I have a particular goal with this equipment, right? And same applies to service. If I'm optimizing for performance, I will provide different level of service than if I'm optimizing for reliability or cost. I have a clunker old Prius, over 10 years old, and I have a not very expensive, but I like it, sports car, right? And they're getting very different attention from me in terms of service, right? The Prius, 5,000 miles, when I get to it, I'll change oil. The sports car is on a maintenance plan, right? Which I bought from the manufacturer because, hey, I like the car. And so that's kind of the different approach in terms of service. So asset performance management allows us to optimize the asset towards this particular asset strategy. The way it does, it basically receives a lot of sensor data and crunches the data, performs all those analytics, looks for any kind of deviation from what should be to what is, applies a risk assessment based on this particular failure. If it happens, it will cost us a lot of money. This particular failure, if it happens, nobody really notices. You can apply all of that. You apply the asset strategy against that. That's what makes it different than just your typical analytics. And now you have recommendations, right? And these recommendations will basically help me to decide what am I going to do about this problem, right? Now, one of the typical things that is being decided is, well, I need to dispatch a person or a crew in order, with a wrench in their hand to do something with this piece of equipment, right? If it's a wind turbine, if it's a pumping station somewhere on a pipeline, if it's a medical device in a hospital, very often I need to deliver some kind of service. And the magic here is to move away from what we used to call break-fix model and move towards predictive or proactive maintenance, right? You want to avoid any kind of unplanned downtime of that equipment. You don't want this equipment to be standing. And remember, very often we are talking about mission-critical equipment. A CAT scanner in a hospital is a very expensive piece of equipment. A lot of hospitals have just one, right? And if there are people who need it because they were in an accident, you don't want to be sending them away to another hospital 50 miles away, right? So it's mission critical. People's lives can be at stake. Jet engine, right? You don't even want to think about that jet engine not operating the way it's supposed to be, right? So there is definitely a lot that goes into that. In fact, in terms of the business processes, there are service contracts, there are SLAs, there are part, labor, and expenses. There are task lists that need to be accomplished with every service engagement. There are dynamic schedules. You monitor the asset condition, you capture the data and send it back to the asset performance management system. And of course, there's all the connectivity and monitoring that you want to make sure is working as well. So that's kind of what makes it an equipment-centric field service management system. Field service management is what we call our application class, right? ServiceMax is a field service management solution. It's a delivery of field service where the equipment is in the heart of it. The data is at the core of the delivery process. I need to understand the life cycle of my equipment. How old is it? Where is it in its life cycle? And the strategy that I'm applying, right? Is it my old clunker or is it my beloved sports car, right? I also need to understand the use and condition. Am I driving in the wintertime in Michigan or am I driving in February in Southern California? Very different conditions. I need to make sure that the equipment is maintained properly. There's a plan that says I should do certain things, change oil, change brake pads, do all these things at regular intervals so that it's properly operating. And last but not least, the people performing the service and their skills are very critical. They need to be matched with the equipment needs. And that's not always trivial, right? A lot of our customers are telling us that their innovation cycle is outpacing the learning cycle of the service personnel, right? They can't learn new things quickly enough because there is so much innovation coming out. So it's a pretty tricky business. So that's what we do with ServiceMax. It's basically an application that allows us to make sure that the service technicians in the field with their mobile devices know what to do. And there are a lot of steps before and after, including scheduling and dispatching and work planning and dealing with parts logistics and entitlements and all these other things, right? But this is not a product pitch. We also have a direct integration with an IoT environment. We call it connected field service, which basically means that a machine can call for service automatically, right? What we usually do is we rely on APM or we rely on a IoT type of environment. We've integrated that, and we can get a service request directly from a machine. And that means that we can then automatically dispatch the crew to address the issue. So kind of together these things allow us to perform what we call predictive maintenance strategy. It's the combination of asset performance management or any kind of IoT environment with ServiceMax, with the service delivery application. Ultimately, it's all about outcomes. And these outcomes are usually threefold. Companies are interested in having loyal customers, meaning that they want to make money, they want customers to buy more, they want customer experience to be great, they want the product quality to be great. Another outcome is they want to have a productive equipment. They want to have the reliability of the equipment they operate. They want to get the best performance, the best return on assets. And last but not least, they want to have efficient operations of the service delivery itself. Right? That's all about cost, visibility, productivity, and compliance of their crews. I'll skip over this. We have some great results. Our customers in a survey report 11% increase in NPS, 12% increase in uptime, and 18% increase in productivity. Right? That's almost one entire day in a week that we are adding to the productivity of a service technician. So we are ServiceMax. We know this business. A lot of great logos are our customers. A lot of assets are under management by ServiceMax. And with that, thank you very much.